So today we will discuss about the hybridoma technique, which I discussed, like I only discussed the name of this technique in my previous video on the monoclonal antibodies. So basically it is a technique, it is genetically engineered technique which is used to make the monoclonal antibodies. It's used to make monoclonal antibodies, right? Basically there are certain ways, or you can say there are certain steps to make the how make the monoclonal antibodies by the procedure of this hybridoma technique. So first is basically the in order to form the monoclonal antibodies, we want a antigen. Basically we want a vector. Now what is vector? Vector is basically a carrier. Okay, let's directly discuss this with example. Okay, consider that we have taken a vector which is we have taken a rat. Consider that this is a rat, right? And I have added a pathogen. I have added a pathogen in the rat, and after some days, obviously after 5 to 10 days, this rat will die due to the pathogen, right? Rat will die. Okay, during the process of when the rat will die, obviously its immune cell will get activated, the immune system will get activated. The immune system gets activated, plus obviously the immune cells will produce the antibodies. The immune cells, or you can say basically the plasma cells, will produce the antibodies, right? Okay, now so basically after that, what is the second stage? After the death, of rat, we will extract the spleen of the rat. We will extract the spleen of rat, right? Basically we want 2 cells from this rat. Basically we will extract the splenocytes. We will extract the splenocytes from the spleen of the what are splenocytes? Splenocytes are basically cells of, or you can say that the plasma cells of the spleen are known as splenocytes, right? We will extract splenocytes, and we will extract myeloid cells from the bone marrow, right? We will extract myeloid cells from the bone marrow, and splenocytes, or you can say the plasma cells, from the spleen. Now the second step is why we have chosen these 4 steps. Basically the splenocyte has the capability to produce the antibodies, right? And this myeloid cell has the quality of rapid division, right? Moreover, these myeloid cells are the immortal cells. They never die, right? But obviously they get these are basically cancerous cells. These are cancerous cells, but they killed by radiations. Right? So this was the purpose that why we have choose these both cells, due to these qualities, right? Splenocyte has a quality of the producing antibodies, right? Now what's the next step? Actually, we have to now fuse these both cells. These are myeloid cells, and these are myeloid cells, and these are splenocyte cells. We have to basically fuse. The second step is basically fusion, right? Basically, a chemical is used to fuse these both. A chemical is used that is known as PEG, polyethylene glycerol. Polyethylene glycerol, right? Polyethylene glycerol is the chemical which is used to fuse these both cells, these myeloid cells and the splenocyte cells. So a new cell is formed, like consider that S multiplied by M, like splenocyte multiplied by the myeloid cells, they form a new cell. This cell is basically known as hybridoma. This cell is known as hybridoma, and it is genetically modified cell. It is genetically modified cell, and basically it has 2 to 3 qualities: that it is immortal, right? Second, it can do rapid division, right? And it can produce antibodies. And obviously this hybridoma will get to the it will divide mitotically. And it will produce a lot of antibodies. Basically this hybridoma is placed in a het medium. Hybridoma is placed in het medium. For what purpose? For basically for testing. In het medium for testing, right? Basically the full form of this het is let me write over here. The full form of this het stands for hypoxanthine aminoterrin thymidine. Basically this hybridoma is placed in this medium for purpose of testing, right? Basically what happened, the cells which basically do not grow, the cells that do not grow are separated out the cells that do not grow are separated out, and the cells that grow, they continue to grow, right? And some cells continue to grow are placed in that medium, and some cells that do not grow, they are separated out, right? And what happened, this hybridoma divides mitotically, and it produces antibodies, right? So this is how the monoclonal antibodies are produced. Monoclonal antibodies, as you can see, there is a single cell known as hybridoma, and from that a lot of antibodies are being produce, right? Basically these monoclonal antibodies are helpful in the diagnosis purpose, and diagnosis, right, in the pregnancy test, right, and more, and there are many other techniques in which these monoclonal antibodies are being used in this today's world, right? So I hope this is clear to you. If you have any kind of queries, you can ask me in the comment section. We're very glad to answer you guys.